This is Geometry Lesson 1-3, which is going to deal with measuring and constructing angles. All right, the set of all points between the sides of an angle is the interior of an angle. So if you look at angle SRT here, interior would be inside, exterior would be outside. Angles are going to be named by their vertex. So you would have to say angle R is the vertex where it opens up, SRT, TRS, angle 1 would all be different names of this angle. Okay, so a surveyor recorded the angles formed by the transit on point A and three distant points B, C, and D. Name three angles. Well, you could say angle BAC, angle CAD, and angle BAD. Notice A is the vertex, so that's always going to be in the middle. You couldn't really say angle A for this one because you're not sure exactly what that's referring to. That's when you want to use three letters and be specific. All right, let's try that again. Write the different ways you can name the angles in the diagram. Well, we can see that T is the vertex, so we could say angle QTR, angle RTS, angle QTS. Now, since these are numbered, you could also say angle 1 and angle 2. All right, so angles are named by their vertex. All right, the measure of an angle is usually given in degrees. Since there are 360 degrees in a circle, 1 degree is 1/360th of a circle. When you use a protractor to measure angles, you are applying the protractor postulate, which means, once again, there is only one-to-one correspondence between 0 and 180. Just much like the ruler postulate, there is one distance between two points. There is one angle in between 2 points. All right, so you can use the absolute value again, meaning you can go from either way. If you go from 0 to 90, it's 90 degrees. If you go from 90 to 0, it is still 90 degrees. Always going to be positive number. Okay, so if you're looking at that protractor, you can see the different ways to look at that. So if you wanted to measure angle COA, you could go from A to C, which is 0 to 45. So that would be 45 degrees for angle COA. All right. So there are 4 different types of angles that we're going to name in this section. An acute angle is an angle that is between 0 and 90. All right, greater than 90, but greater than 0, but less than 90. A right angle is exactly 90, and is use the little red box there or a little box there to show that it's a right angle. An obtuse angle is between 90 and 180, so greater than 90, but less than 180. And then a straight angle is a straight line that forms two opposite rays that measures exactly 180. So if you're looking here, find the measure of each angle, then classify each as acute, right, or obtuse. So let's get the pen out here. So it wants WXV. So WXV would be this angle right here. That is 0 to 30. So that is 30 degrees, which would be an acute angle. Let's try ZXW. That's this guy right here. So what do we got here? That's 30 there. And that's 130 there. So 30 to 130 is 100 degrees. And then that would be an obtuse angle. All right, so that's how you use a protractor to measure those angles. Okay, congruent angles are angles that have the same measure. We use tick marks for segments. For angles, we use what are called arc marks. And these two little red marks in here would indicate that the angles are congruent. Remember, congruent means they are the same. And the little equal sign with the squiggly poo over it, that means equal. Okay, so angle addition is just like the segment addition postulate, except it deals with angles. And so here's your angle addition postulate. If you've got the blue angle and the red angle, and S is on the inside, then the blue plus the red equals the whole angle. So the two parts equal the whole thing. All right, so let's try that here. Angle XWZ, so the whole thing is 121, and XWY is 59. How would I find YWZ? How would I find what's left over? Well, I would take 121 minus 59, which would be what? 62? So 62 degrees. Angle addition. Okay. Angle bisector is just like bisect means, again, cuts in half. So if it says that JK bisects LJM, that means that it bisects the angle. So that means that LJK and KJM are the same. So those two angles would be considered congruent. All right. KM bisects JKL. The measure, that's what that M stands for in front, of JKM is 4x plus 6. So this is 4x plus 6. We also know this bisects it, so those two would be the same. MKL is 7x minus 12, so in there. So what am I going to do? If I know those two are the same and I have that expression, I can set those equal. So 4x plus 6 equals 7x minus 12. Subtract 4x, add my 12, which is 18. So x equals 6. Plug 6 in for 4, which is 24. 24 plus 6 is 30. So each one of these angles is 30. And then the whole thing, well, I just asked for JKM, so that would be 30 degrees. Bisect cuts in half. All sorts of different vocabulary words, things that you're going to have to know when you're going through this course. So bisects means cuts in half. Let's try another one like that. If they don't give you a picture, you've got to draw a picture. So this says QS bisects angle. Whoops. Let's go back here. It says QS bisects PQR. So I've got PQR, and it says QS, so that's S, bisects it. So that means I know those two are the same. So PQS is 5y minus 1. And then PQR, so that's the whole thing. That's this whole angle out here, is 8y plus 12. So I've got to do this a little bit differently. Well, I know the whole thing is 8y plus 12. And I'm going to have to set that equal to these two added together. Well, if they're the same, though, and this is 5y minus 1, then this also has to be 5y minus 1. So I'm going to add those together. Well, 5y plus 5y is 10y, and minus 1 is minus 2. Now I can do my algebra. I'm going to add 2 to make that 14. I'm going to subtract 8y to make that 2y. And I'm going to divide by 2 to get y equals 7. Okay, now it asked for PQS, which is this one. So 7 times 5 is 35. 35 minus 1 is 34. All right. So all sorts of different things going on here with angles. That is a wrap on lesson